So hello everyone, this time virtual out of the cloud for our first presentation here, Cisco Multi-Cloud Networking. It's a topic dear to our heart. It's a topic we do for quite a long time when we can speak of a long time in IT. Where we mean not decades, we mean at least years, so about 4 years or so, we're in that product space. Um, so today, I'll have my great co-presenter with me, Max Ardica. My name is Lucas Kradiger, and we thought we give you guys a little bit of variation of accents. One side, you will hear a little bit Swiss-German accent out of a US location, and then we have the Italian accent out of a French location. We're literally in the cloud around the globe, so bear with us and let me get started and show you a little bit what we have and what we did around multi-cloud networking. So cloud is the program. We're looking at the overall requirements which these days customers have by embracing the cloud. And definitely connectivity is something which Cisco always tries to be first and tries to address these things as we go. But nevertheless, there is with the connectivity visibility part, which is equally important. I mean, think of it, we configured routing protocols or switches for so long to make connectivity work. And then we had a trace route or a ping in order to show us the very, very bare of where the packet goes. Guess what? The cloud doesn't really have a CLI where you do a show route or a show a ping or something like that. So given that, we need to kind of bring the visibility parts back. Nevertheless, networking is all about application. So how we can elevate the visibility of not just the network, but also the application of the network is an adjacent requirement there, and follow the application as it needs. And then last but not least, the security part. Zero Trust is program, and we believe that in these heterogeneous environments of public cloud, private cloud, hybrid cloud, multi-cloud, the security part is often not as exposed, but needed to be as exposed and available as it is today in the more classic world. Now, with this said, and me starting with the connectivity part, it's not just about the public cloud. I mean, you see me here putting up Google Cloud, GCP, AWS, or Azure, but connecting to AWS, to Azure, to GCP, just from your PC over internet is one of the aspects. We have a lot of application communication happening either from an on-prem data center, from a co-location, or just between the clouds, from different compute and different application platforms, i.e. hypervisors or containers. So it's not just the connectivity, it's the operation and the troubleshooting of it. The optimization, if it comes to regional connectivity and it comes to path selection or the integration with an SD-WAN function, maintaining consistency across a heterogeneous environment. I mean, let's be clear. Every cloud, private or public, is somehow built based on common functionality, but the primitives or the language we're using in these cases are completely different. And then last but not least, there's always this ominous L4 to L7 services, firewalls, load balancers, proxies, etc. We want to make sure that these functionality, these service functionality, is it third party or is it Cisco owned, is being well integrated in such multi-cloud environment. Now, I spoke a little bit about the past. We did this under the name Cisco Cloud ACI. We had a controller called the Cloud APIC, and it's 2022, and we need to rename things a little bit as our scope, our purview massively extends, and that's where the old controller became the Cisco Cloud Network Controller in its ability to expand just beyond the only ACI fabric on an on-prem or the ACI policy model from a cloud perspective. So when I'm saying this, what is new? First of all, we support any kind of on-prem networks you have, data center with an ACI fabric, data center with a Nexus Dashboard fabric, controller fabric, just being there in a co-location or into your own premises to your availability. We connect to external networks, which could be branch campuses or just another co-location where you need to. And we connect to the cloud as well as the whole networking within the cloud. And I just want to re-emphasize that we expanded from an ACI and ACI policy purview totally into the networking and security capabilities across these different locations where a cloud could exist or could be operated. Now, just a little bit on the deployment models which we support then, and after that, I'm going to be quiet and let Max go into the demo, which is actually the whole second part, the major part of the presentation today, because we want to show you how real this is. But when it comes to the deployment models, we want to emphasize that we can run in a cloud-only environment. So think of it, you're running everything in, for example, Azure. We can do the whole networking on top of intra-cloud, single region, multi-region, or then expand to another cloud. Is it Google Cloud or is it Azure, or to your on-prem data center if you wish, if you're looking at a hybrid one. But it's important to us that we can share with you there is a way to make the network functionality more versatile at the speed of the cloud providers itself, and not only versatile, but also uniform across the different cloud providers. The said, when we go into hybrid cloud, meaning public, private, or on-prem, and the CSP, the cloud service provider, we provide integrated functionality into our prime on-prem data center fabrics, either controlled through the APIC, our ACF fabrics, or controlled through the Nexus Dashboard Fabric Controller, formerly known as DCNM, which is our standalone part, the NXOS part. Now, it would be incomplete if we would only look at, hey, this is the cloud, hey, this is the Cisco data center, because they're user which require to connect as well. And that's where the integration when it comes to an SD-WAN part, or any kind of branches, or just some other data center network or co-location placement where you need to connect to the cloud with an edge router there. So we're supporting all of these different deployment models as a mix and match possibility at your liking. I mean, this is the slide work you just saw, and what I want to hand over to Max, which actually will guide you guys through a whole demo of this hybrid cloud, public cloud only, left and right, and he will give you much more to this than just me speaking about the slides here. But remember, Switzerland has a flag with a cross in the middle, so it's a big plus. Unfortunately, France and Italy has kind of a vertical minus. So I'll hand over to Max and give him the rest of the time.
And what I'm gonna show you now is essentially a live in quote demonstration of this hybrid cloud solution that Luke has introduced, where we want to be able to interconnect on-prem or more than one on-prem VXLAN VPN fabrics with public cloud. In my case, I have AWS and Azure cloud I want to connect to. And this is a new functionality. As Lucas said, we used to have Cloud ACI that was used to interconnect ACI fabrics to the public cloud. A month ago or so, we introduced this new functionality with also VXLAN and VPN fabrics, right? And that's what drove the change of naming convention for the Cloud Epic that became the Cloud Networking Controller. So the solution building blocks for this demo are the Cisco Cloud Network Controller, which is again the controller that we deploy in the public cloud that drives the provisioning or configuration in the different types of clouds. The virtual router Catalyst 8000V, which represent, if you want, the hook that we put in each cloud to allow for the extension of connectivity between that cloud and another cloud, or that cloud and on-prem, when we talk about the hybrid cloud solution. And third, last but not least, the Cisco Nexus Dashboard, which is the Cisco compute platform that hosts different services that are needed for the provisioning monitoring and troubleshooting also of this hybrid cloud end-to-end solution, right? And on top of this Nexus Dashboard compute platform, we are going to run a couple of important services. One is the Orchestrator that we will see is the single pane of glass from where I can provision the entire configuration and connectivity for the whole solution. And also the Nexus Dashboard Fabric Controller that maybe some of you knew with the name DCNM before, which is basically the controller that manages the on-prem VXLAN VPN fabric. Okay? So without any further ado, the demo topology is this. Very quickly, on the left, I have my on-prem fabric, which is very simple, 2 leaves and 1 spine. That spine performs the role of border gateway spine because it's essentially my point of extension of connectivity out of that fabric toward other fabrics on-prem or toward public cloud location. And we will see we use VXLAN VPN for that connectivity. And that VXLAN fabric also have another on-prem device, part of what we a construct, the NDFC called external fabric, which in my case is a Catalyst 8000V, so it's a virtual router, but in general is an IPsec device that is used to establish IPsec connectivity and routing with the public cloud. Okay, it's basically allowing to create the underlay connectivity between on-prem and the public cloud. Okay. And on the right, we have the 2 cloud presence, Azure and AWS, and we already did, as part of the demo, some pre-configuration where we created what we call it as InfraVNet and InfraVPC, which are basically these containers of object, like the cloud network controller, which we will see then will provision configuration in each cloud, the virtual router, the Catalyst 8000V, a pair in each cloud that, as said, establish connectivity back to on-prem. And then we have, depending on the flavor of cloud, the NLB in Azure or the transit gateway TGW that will allow to connect user VNets, user VPCs, or in general user subnet, if you want, to these InfraVNet and InfraVPC container to be able to establish subnet to subnet communication across between clouds and on-prem. Okay, and so what we want to do in the first part of the demo, and what I'll show you, is how by interacting with a single system, which is the Orchestrator running on Nexus Dashboard, that Orchestrator will be able to push configuration on-prem and in the public cloud through interaction with the local controllers, NDFC on-prem, cloud network controller in the cloud, to basically create an IPsec and BGP underlay connectivity between cloud and on-prem, and on top of that, build the famous VXLAN VPN control plane data plane, which is becoming the de facto standard to establish, connectivity between different fabrics or between on-prem fabrics and public cloud. And that VXLAN VPN control plane data plane is what basically will carry then the user traffic when I have an endpoint of a user on-prem that wants to communicate with an application in the public cloud. Okay, so first step is basically how do we provision that infra configuration, right? That underlay plus overlay that will make my system ready to interconnect entities. I'm doing a quote-unquote live demo in the sense that I'm using a video for 2 reasons, because, one, the most important, the cloud is slow, right? It's a great thing, but it's slow. So if we do a live demo showing stuff in the cloud, we may stay here till for the next 4 hours, okay? Second thing is because the demos gods are always there looking, right? So if I did a live demo, something bad would happen, and I want you to get the content and see the demonstration rather than seeing me troubleshooting maybe some issue, okay? So we start the demo, we are connected to the Orchestrator, right? And in the Orchestrator, we see that we have our different sites, okay? We have 2 cloud sites, AWS and Azure, right? One, it's a region on the west coast of US, one is the Azure region on the East Coast. And then we have in Australia, and in the lab, we have in Sydney, we have our on-prem. Okay, so let me start the demo. The Orchestrator is able to show you this for the simple reason that these sites are basically managed by the Orchestrator, right? So the first step that I already done, I have onboarded this fabric. So I basically connected my orchestrator with the different controllers, the on-prem controllers and the cloud controllers. And I onboarded that on the Nexus Dashboard. Once I do that on the Nexus Dashboard, these sites are exposed to all the applications that run on the Nexus Dashboard, including the Orchestrator application, which is what we use for this inter-site connectivity establishment. Okay? So I set this fabric as managed, and I move on, and basically I go into the site connectivity, right? And site connectivity is really where I need to provide the connectivity between the sites and create that IPsec and BGP peering. And so I look at the site connectivity, and what I'm going to do, the first step, I need to tell the orchestrator that there is an on-prem IPsec device that I want to use to build my IPsec tunnel with a public cloud, right? So here, I add my on-prem IPsec device as a managed device because I want the orchestrator to configure the device through the on-prem controller. So I select the external fabric that I have on-prem, and I select the device which is part of that external fabric, which is, as I told you, in my case, is a Catalyst 8000B. Could be whatever device that can be managed by NDFC that supports IPsec. I specify the interface on the device that connects to the internet because I need to have, obviously, IP connectivity through the internet to the public cloud to build my IPsec, and I specify my next stop address. Okay, so the IP address doesn't really matter. It just allows me to connect to the public cloud. Once I define that IPsec device, I need to tell to the orchestrator that I want my Sydney, the VXLAN VPN fabric, to use that IPN device to connect to the cloud or to connect to whatever external site. So I specify the device that I just defined, right? And I'm basically done with that. So I know that every time my VXLAN VPN fabric wants to communicate out, it will need to build an IPsec with that specific on-prem device. The other thing I need to do is I go on the clouds, on the two cloud side, and on the cloud side, I need to do basically two simple things, right? One is enabling, it's called ACI multi-site because the GUI needs to be changed and be generic multi-site, right? It's not ACI here that we're doing. I need to enable the multi-site function for that public cloud. And I need to tell the orchestrator that Azure cloud, who do I want to connect to? And in my case, I wanted to connect to the on-prem VXLAN VPN fabric, right? So I'm going to go ahead and see that I connect to Sydney, right? And I go on. Connection type is going to be the public internet because I could also have a private connection if I have express route, but in my lab, I use the public internet that uses IPsec, okay? By default for security. And it connects IPsec to the on-prem device that I defined earlier, okay? I do exactly the same thing and accelerate a bit for the sake of time. I do exactly the same thing on AWS. On AWS, I say I wanted to connect as well to the same Sydney site, okay? And once I'm done this, I hit deploy from the orchestrator, right? So I gave my cloud the information that I want to connect to the on-prem fabric. The orchestrator now push the configuration to all the controllers. And here is where all the magic happens, right? So all the magic happens, and after a few seconds, you see lines that start appearing between my public cloud and the on-prem fabric. And after 1 minute, 1.5 minutes, and I'm accelerating a bit, this line from red turned green, which means my VXLAN VPN control plane and data plane is actually up and running. Okay. Now, this basically shows you how that VXLAN VPN connectivity underlay plus overlay can be set up with essentially 4 clicks on the orchestrator. But once I've done that, I haven't achieved any connectivity yet because I haven't deployed any subnet, any endpoint, any network, right? So if I go back to the slide, this brings me to the second part of the demonstration that I'll do in the next 7-8 minutes, which consists in building subnets and endpoints that then needs to communicate with each other across this hybrid cloud environment, right? So We're going to deploy a subnet on-prem with a specific IP address, which is not relevant, but we'll need to have an IP address, obviously, a prefix. We are going to also create in Azure a user VNet with an associated subnet, and on AWS, a user VPC with an associated subnet, okay? And when we create this VNet and VPC, we want them to be connected to my infra container so that through the IPsec and VXLAN VPN control plane and data plane that I built, this blue subnet and this orange subnet can actually communicate with the on-prem entities, with the on-prem subnet. Okay? So that's the goal of building this hybrid cloud connectivity, right? And so
if I wanted to add a fourth data center that was my ACI fabric, would that work in your topology, even though ACI is not running VXLAN on the top?
Okay, so today on the same orchestrator instance, we cannot mix on-prem ACI and VXLAN VPN fabric, okay, in the current implementation. So I could do the same topology with an ACI fabric and the cloud, or I can do with the VXLAN VPN fabric, or more than one VXLAN VPN fabric, actually, right? I could have multiple NDFC instances, but they need to be fabric of the same type on-prem. This is in the current implementation, but obviously architecturally, the goal is to basically be able to also have heterogeneous on-prem fabric supported in the same multi-site domain.
So Max, if I'm understanding you correctly, I could have a VXLAN fabric. I could have multiple physical data centers with VXLAN fabric, or multiple data centers running ACI fabric attaching to the cloud, but I can't have one and one.
You cannot have a mix of VXLAN VPN and ACI on-prem connecting to the cloud and all part of the same multi-site domain. Not today. Not today, but that's where we want to go.
And is that roadmap?
It is in the roadmap. It's a future roadmap, so something that probably calendar year 23. I don't have a date to give you because it hasn't been committed yet, but that's the direction where we want to go, right?
So maybe to add one or two things to what Max said, the architecture is the same. What the difference is the policy aware versus the policy-less infrastructure. In ACI, we use a tighter segmentation framework, which would not be existing in a standalone network. Now, when we mix the policy-aware and the policy-less infrastructure, what do we do? Do we do a least common denominator, which would then be policy-less? Or are we going to kind of a policy translation capability that application on an NXOS fabric would not have a tighter segmentation? On the ACI side, it would. And how you mix and match that. It is, next to us implementing, is actually the easier part to mix it. But for the user, the operational parts become pretty difficult to know when do I enforce, when I don't I enforce. But apart from that, the architecture is the same, the transport is the same, the elements are the same. The difference is literally on what is the on-prem fabric. Everything else is more or less looking equivalent on both of the base data center fabrics.
In order to provision this subnet, what we do it from the orchestrator, right? And I don't know if you're familiar with how the orchestrator provision configuration, but uses this concept of templates, which are containers of configuration, if you want. And what we want to do, we want to create one template with the VRF, which represent my routing domain. And I want that template to be basically associated to the on-prem site and the cloud sites. That's basically my indication that I want a single routed domain to exist between these three locations, okay? And then I want to create what we call it an on-prem template only associated to the on-prem site to define a network, my 172.16.10 that I showed you in the previous slide, which is associated to the same routing domain and will basically need to route then traffic to the VNet subnet or the VPC subnet that we deploy in the cloud, okay? And so real quick, let me show you how this looks like from an orchestrator perspective. So let me move over here. So I go into the, let me go here. I add a schema, which is the container of this template, right? This is just a hierarchical way to organize your configuration on the orchestrator. But you can think about schema, it's a container of template. What matters really are the template inside the schema. And inside the schema, we said we're going to deploy two templates, right? The first template is the one that we call the stretch template, which is going to be used to define my routing domain. I want my VRF to exist end-to-end, which means I want to route between my on-prem and my cloud locations, okay? So I define the template, I associate to the default tenant that we use for NDFC integration, and then I associate that template to my three sites because I want, as I said, the same routing domain to extend between the three sites. Once I'm done that, I need to define the configuration that in this template that I want them to push to these three sites. And the configuration is, as I said, the VRF, the routing domain that needs to be extended. So I call this VRF VRF1, and then I need to do some configuration at the site level for the same VRF, for the same VRF object, right? On the on-prem site, I need to tell the orchestrator I want to deploy this VRF on the leaf and on the spine/border gateway because I want endpoint to connect to the leaf in that VRF, and I want the VRF to be extended by border gateway to the cloud, okay? So I do that configuration for the on-prem site. In the cloud, the VRF is always equivalent in AWS to a VPC and in Azure to a VNet, right? So if I go at the site level for Azure, I click on VRF1, I need to specify in which region I want that VRF, which is basically a VNet, to be instantiated, right? So I pick my region and I specify what is the subnet, the range, the prefix decider available for that region, and the specific subnet that I want to instantiate. In my case, it's a 10.1.0/24, okay? So I accelerate a bit here. So I just create basically a VNet with a subnet in it. In AWS, I do exactly the same thing, right? I specify my region, which is US West 1. I specify a CIDR for that VPC that I'm going to go create, and I'm going to define which subnet I want to deploy in that user VPC. Okay? Now, what I don't show in the demo that I've done under the hood at that point is that I connected a VM on-prem to that to the subnet on-prem that I'm going to go and create now in a second, right? Because here I'm going to deploy my VRF, and this basically push the VRF to the three location. After I've done this, as I told you, if you notice, I created subnet in the cloud, but I haven't created yet a subnet on-prem. And I'm going to go and create a subnet on-prem in a second, right, by defining a new template which is dedicated for the on-prem site, right? So accelerating a bit, I create my template, I called it, I associate it to the default tenant, and inside the template, if you see, I'm going to create a network, which is a subnet, which I call it the demo VN virtual network 1, associated to the same routing domain that I already created, okay, and give a subnet to that network, right? And the subnet I give is the 172.16.10. Once I've done this, again, I'm going to go and provision, accelerate a bit for the sake of time, but this is basically orchestrator configuration. I'm going to go and deploy that configuration that basically pushes the network creation on-prem. And at this point, if I stop 1 second and I go back, I basically went to create these three constructs here, right, that I show in this slide. And they will leverage the VXLAN and VPN connectivity that I built in this part, in the first part of the demo, to allow a VM on-prem to communicate with the VM in the cloud, okay? And the rest of the demo will show you that actually I can go on a VM on-prem and essentially ping, right, my default gateway, and then going to the cloud, I can show you the VNet with the subnet, I can show you the VPC with the subnet, with the EC2 instance that I attach to it, and then I can show you that essentially, and I will provide you the full end-to-end demo so that you can see everything at your pace, right? But it shows basically that then from my on-prem VM, I can ping my VM in the cloud, Azure, and VM in the cloud, AWS, okay? And so this basically ends this hybrid cloud demonstration. obviously the focus was mostly on the connectivity, right? As Lucas said, the connectivity is not the only thing. We also want to be able to provide visibility into what's going on in the cloud, because that's not very easy to find that information on the cloud native dashboards, right? And also give you capability of doing service integration, right? And all these items will come as part of this solution, right? Right now, the first step was to basically be able to give you an easy way to establish that hybrid connectivity. And also, what I don't show for the sake of time, but will be in the demo that I provide to you offline, is that in addition to provide connectivity from on-prem to the public cloud, through the Orchestrator, we can also establish connectivity cloud to cloud using still the external VPN between the cloud router, or inside the cloud between two regions of the same, for example, AWS cloud provider, okay? And so the Orchestrator is able to basically fulfill all these three use cases with a very similar workflow, right? Hybrid cloud, cloud to cloud, or intra-cloud inter-region.
Yes, so Max, maybe one point you could
Yes.
Why are you showing actually a video? Can you tell us a little bit? I think you mentioned it earlier. But...
I mentioned it because to build a video of 30 minutes when you interact with the cloud, it takes 2.5 hours, right? The cloud is a beautiful thing, but it is not the fastest place where to provision configuration. And not because the tool provisioning the configuration is low, is because the cloud takes its time, right? When you create an instance, you create a VPC before the VPC available, the subnet is available, the instance is available. It takes time, right? And so it doesn't offer itself very well for a live demonstration when you have 20 minutes, right? If that's what you were aiming to let me say, Lucas.
Exactly.
Yes.
But
okay.
what about the tools you used? So all of the functionality which we provide is shipping today, right?
Everything you have seen is actually shipping code today. Correct.
And it's not version 0.01. It is actually
is not actually the orchestrator. Yes, the orchestrator is NDO Orchestrator version 4.02, which we are at release 4 of the orchestrator, right? The NDFC also has 4 or 5 releases under its belly or 3 at least, since we changed from DCNM to NDFC. And the cloud controller is just a rebranding of the Cloud Epic, but has been around for Cloud ACI for 2-3 years already. Yes, so it's mature technology, is not bleeding edge.